Hello everyone, welcome back to another video. My name is Mirza. In this video we are going to do a problem on cantilever beam with uniformly varying load. So without any further delay, let's see the problem. So here is the problem. A cantilever beam of length 4 meters carries a gradually varying load. Gradually varying load, that is UVL. So I will write here UVL, uniformly varying load, and set 0 at the end, 0 at the free end, to 2 kilonewton per meter at the fixed end. So the gradually varying load or uniformly varying load on the beam, it is 0 at the free end and it is 2 kilonewton per meter at fixed end. Draw shear force and bending moment diagram. Okay. So the figure may not give in the question. So you need to imagine whatever given in the question. A cantilever beam, so 0 at the free end, let's say B and A. Okay, so here it is 0 and here it is 2 kilonewton. That means here it is maximum and here it is almost or 0, exactly 0. So it will be like this. So gradually varying load, okay, like a triangle. Okay, so now the length of this beam is given in the figure, that is 4 meters, clear, and this will be, that is a maximum, that is 2 kilonewton per meter, clear. The first step is to find out the support reactions. So I will write calculate support reactions. So summation of all the vertical forces equals to 0. Summation of all the vertical forces is equals to 0. So that is RA in case of uniformly varying load. So we have to remember that we need to take the area, that is RA, which is positive. So it is upward direction, upward reaction, vertical reaction, right? For this upward reaction we have a resultant reaction, that is uniformly varying load. So what we do, we take minus 1 by 2, that is half into base into height equals to 0. So what is base here? Base is 4 meters and height is 2 meters. Okay. So from this we can write RA equals to half into 2 into 4, and we get RA equals to 4 kilonewton, and no need to find out the reaction at B because it says that at the free end it is 0. So no need to find reaction at B. So directly we jump into step number 2, that is shear force. To find out shear force, step number 2 is to find out shear force, which is represented by F, right? So shear force at A. So I will write the sign convention here. So if this is my section, if I cut any section, so if it is upward direction on your left, we take positive, downward direction on your right, we take negative. So most of the students get confused here. So please be careful while choosing sign. Okay, clear? So in all the problems in the previous videos and our kind of problems, we just took the forces which is on my left. So I'm moving from here to here, right? I'm taking all the forces my left. So always my sign convention which is going upward direction, that is RA, which is shear force at A, will be positive. So I can write that FA equals to RA, because I'm taking section at point A. So what is RA? That is 4 kilonewton. So put the 4 kilonewton here. So that's it. We got shear force at A. So now I'm moving this to B. So we know that shear force at B, and there is no load applied on the free end of the cantilever beam. That means it is having 0. So shear force at B, that is FB, equals to 0. Okay, so I got FA and FB. Now the third step is to find out bending moment. So step number 3 is to find out bending moment. So let's find out bending moment. Yeah, step number 3, we need to find out bending moment. Bending moment, which is represented by M. So bending moment at A. So I have to take a section here, and for sign convention for bending moment, so if it is hogging, if the load is making the beam hogging, that means we take positive. If it is the making sag, if the load is making the beam sagging, that we take positive. If the load which makes the beam into a sad smile, we take hogging, right, which is negative, right? This is the sign convention. So yeah, so shear bending moment at A. So I can write that MA equals to minus, so I have to come here, I have to take this, that is minus half into 2 into base, height into base, into the maximum bending moment will occur at 4/3. So here there will be a maximum bending moment. So here somewhere at point here. So we take, for uniformly varying load, we take 4/3, right, because the span length is 4. So now from here I can get minus 5.33 kilonewton meter. So this is the bending moment at A. We know that bending moment at B is 0, because it is free end. So all the forces, all the movement is at A. So bending moment at B, that is MB, equals to 0. So now we got MA, MB, FA and FB, so that we can draw shear force and bending moment diagram. So let's draw shear force and bending moment diagram. In order to draw shear force and bending moment diagram, that is SFD and BMD, so we need to draw the free body diagram of the beam, which is cantilever. So having no load at B and having maximum load, that is 2 kilonewton per meter, and it will vary gradually, it will decrease. So this is your given beam. For that we got shear force and bending moment values. So extend the reference line. Extend the reference line. Okay. So now to draw shear force, we need to draw the baseline first. So this will be 0, 0. So whatever the value which is positive, we draw above this. Whatever the value we got negative, we draw below this. Or if it is 0, that means we know that shear force, that is FB equals to 0. That means the diagram should touch the baseline. Same as in case of bending moment. So first we draw shear force. We know FA value, that is 4 kilonewton, which is positive. Raise up to certain height to represent 4 kilonewton. Let's say this will be the 4 kilonewton. If it is 2, it is more than 2, right? So increase little height. Okay, this will be your 4 kilonewton, right? So from here there is gradually decrease in the shear force, and it should go not the rectangular shape, it should go in a inverse parabolic shape. So this will be positive. Okay, we can shade this part to represent shear force, right? So now this is your shear force diagram. In order to draw bending moment diagram, we need to draw a baseline. Okay, then so little, yeah, here maintain some distance between these two. So it will be our baseline. So we got minus, that is MA equals to minus 5.33 kilonewton meter. So that means it is in minus, it should be below the baseline. So I am just dragging this down to a certain distance to show 5.33 Newton meter. So what is the units for bending moment? It is Newton meter. So the formula for this is the load into perpendicular distance. So here is the distance, that is 4 meters. Okay, so now from here there is at B, that is MB, moment at B is 0. So in order to draw this, we need to go a parabolic shape which is quite opposite to this. So this is your bending moment. So the property of the cantilever is always same. So whenever you heard about cantilever, so the free end there will be movement will be always 0. So you need to remember this so that you can save some time in the exam. So no need to just put the values for shear force and bending moment. If it is free, that means there is free movement, there is no movement. So here all the movement, all the shear force will act here, and the bending moment will be maximum here. So that is why you can see the shear force and bending moment. The raise of load shear is happening at A, right, and it is coming down, the graph is coming down, or you can call the diagram is coming down to gradually to 0. So this will be your negative, right? This will be your bending moment diagram, right? Okay,